Recording. There we go. We are recording. Monday, December 2nd, Geometry, Chapter 5, or Section 5-1, Classifying Triangles, and it begins on page 188. The usual suspects are here. So this chapter, you students, you Euclidean geometrists, need to be really spot on with your vocabulary. But you're finding that throughout this entire text, that there's a ton of language in this mathematics, in this study, and particularly all those angles that you had to learn to decipher and define and memorize. Now we're going to start applying our vocabulary skills to triangles and all the particulars about a triangle and how we can prove their congruency and similarity. So the very first section is just on classifying triangles and the anatomy of a triangle and several words that you're going to want to put to memory. So the first page on 188 just talks about what you learn, and it says you're going to learn to identify the parts of triangles and to classify them. The next page is very interesting. They spent a lot of time making this tactile. Unfortunately, it probably just feels like a bunch of texture to you.
Yep.
Yep. It is kind of cool looking. I mean, what they have is it says optical art is a form of abstract art that creates special effects. And by using geometric patterns, the design at the right looks like a spiral staircase, but it is made of mostly triangles. And so you can kind of make out, if you start at the very top left corner and you finesse it, you're really, really careful, you can go along the top line and then you get to the top right and then you come at a slight angle back to the left again and there's a very thin wedge of a triangle. And then they just kind of keep doing that all throughout the drawing. They have these thin wedges of triangles that they put together, and they just spiral around until they get to the center where it ends up being several triangles, but they form rectangles and a square in the center. But, it's for the visual learner to just note that putting these black and white triangles together and spiraling them around, it creates this optical abstract art. But anyway, I always feel bad for the person that spent so much time creating the tactile because they looked at it with their eyes and said, oh, doesn't that look really neat? They didn't realize that if you feel it, it doesn't feel like a whole bunch of texture, doesn't it? Yeah.
It's like a square to me.
Yeah, it's just a big old square with texture in it.
That's so crazy.
I know.
I can kind of feel that triangles.
Can you kind of? Yeah, you can kind of make out. I wish if they would have made it maybe the size of the entire page, then it might have been a little bit easier to make out, but making it, only about half the page. Too compressed. Oh, well. All right, turn your page, and we'll head on to just talking about a triangle. Paragraph of information here. It says, in geometry, a triangle is a figure formed when three non-collinear points are connected by segments. Each pair of segments forms an angle. The vertex of each angle is the vertex of the triangle. Triangles are named by their letters at their vertexes. Triangle DEF would be written with a shape indicator and a T and then the capital DEF. You see that in Braille?
Yep.
Okay. All right. Then we turn the page and they're going to give us a tactile and kind of the anatomy of a triangle. And this is a decent tactile, it looks like. We have 3 sides, but now we're thinking like Euclidean geometry students, and it said 3 non-collinear points. Remember that word collinear and non-collinear back from like chapter 1 or 2?
Mm-hmm.
Yeah. So non-collinear means not on the same line, right?
Yeah.
So they actually create a plane, and then when we connect these 3 points, we get a triangle. Good morning, Abby Sue. Good morning. Miss Rahel, get you all set up. So we have a triangle. If you go up to the top left corner, they have a little mini arrow indicator, and they're labeling this the vertex. And then this particular vertex is point E, capital point E, where those 2 segments come together. And also, they're labeling to the right, they have another little mini arrow indicator pointing to the inside of the triangle where those 2 segments come together and form an angle, right? And that's what we did a lot of study of last chapter. Then if you go from point E, from the top left vertex, and go down the left side of your triangle, down to vertex D, down on the bottom left, and that side, they're labeling that a side. They have a little arrow indicator to the left of that side, and they're just saying that that is labeled a side. So we kind of know that. This is kind of review on triangles, but triangles have 3 sides. And then from the bottom vertex D, if you go immediately right, you're going to find vertex F.
Is this a new one we're doing?
Yeah, we're doing a new section, chapter 5-1. We're going to learn about classifying triangles.
Okay.
Abby just got here. All right, so they're labeling this triangle DEF. All right. The sides, it says down at the bottom underneath your tactile, the sides are line segment DE, line segment EF, and line segment DF. The vertices are D, E, and F, and the angles are D, E, and F. Okay? And so all this information, all this way of labeling things, it's all coming to use in this particular section. Right?
Mm-hmm.
Okay. All right. Turn the Braille page. Miss Angelica, we're in the midst of your print period. And it should say in chapter 3, I'm kind of in the middle of this page. The first part of it says read geometry, read the symbol triangle as triangle, right?
Mm-hmm.
So you have a Braille shape indicator T for that. Okay. And other names for triangle DEF could be triangle FDE and triangle EDF. You can name them by any start of any vertices, okay? So you don't have to name it by the bottom left vertex. You can start at any one and name it. But when you're naming the angles of your triangle, you would still name them appropriately with the vertex in the middle. So angle D, you could also name angle FDE. Remember that from naming?
Mm-hmm.
All right. Okay, it says in chapter 3 you classified angles as acute, obtuse, or right. Triangles can also be classified by their angles. All triangles have at least 2 acute angles. The third angle is either acute, obtuse, or right. So then, if we turn the Braille page, it's at the very bottom of the print page, and we have a tactile showing an acute triangle. So take a look at that. It's pretty nice tactile. It's nice and big. You have your 3 sides. In the top right vertex, they're labeling that 60 degrees. The left one is 80, and they've labeled it on the interior. They labeled it on the exterior and then have a little line indicator pointing to the inside. And then the bottom angle, bottom measurement of the interior angle is 40 degrees. Right? And this is an acute triangle because all the angles are less than 90. So you know that 2 of them will always be acute, and then the other one you identify is going to either be acute, obtuse, or right. So this one you can tell that 40, 60, 80, they're all acute. How much do these add up to? 180.
Yeah.
180.
Yeah, 180. Interesting. All right, let's keep that in our heads. All right, and down at the bottom underneath the tactile says all acute angles. All right, turn the page. Take a look at this big old triangle here. We got really long sides, kind of a skinny one. Don't get thrown off by it. Yeah, so let's see. So Jessica said 43 degrees. That's the bottom
120.
angle. 43. All right, the top angle in this particular drawing is how many degrees? 17. Good.
One in the middle is 120.
And the one in the middle to the left is 120 degrees. So what kind of triangle do you think this is going to be?
Obtuse.
Obtuse.
That's right. So notice you have 2 acutes. You're always going to have 2 acutes. And then the leftover angle, this one is obtuse. It's 120 degrees. What do these add up to? 120, 43, and 17. 180. Aha. Interesting. All right. Let's turn the page and take a look at the next triangle. All right. We have triangle floating out here in the middle of our page. Our top left angle is how many degrees? 30.
30.
Our bottom right angle is how many degrees?
60.
Good. And what's our bottom left angle?
90.
90. How do we know it's 90?
Learn the square.
That right angle indicator. Good. Excellent. You're learning the code of these tactiles and drawings. You don't always have to be told it's 90. Most of the time you'll have that little right angle indicator. So what kind of triangle do you think this is?
Right angle.
A right triangle. Not a wrong triangle. Not a left triangle. It's a right triangle. How much does this do? 30, 60, 90.
180.
180. Notice we have 2 acute angles, and then the other angle is a right angle. So that third angle is always going to identify your triangle. It's either going to be acute, obtuse, or right. Okay? So as far as this vocabulary is concerned, not too bad. You already know all these words, don't you? From identifying your angles. And now what can you draw a conclusion from, even though I believe it's coming up in a later section, but how many degrees are always on the interior of a triangle? How much do they add up to? Always, always, always. 180. We just did a little bit of chapter 1 work, didn't we? We did deductive reasoning. We said, oh, how many degrees on that first acute triangle? 180. How many degrees on the obtuse triangle? 180. How many degrees on the right triangle? 180. Huh. Well, we could come up with a statement there, couldn't we? That the sum of the angles, the sum of the interior angles of a triangle will always be 180. We're going to learn that in a couple sections from now, but you already know how to do that reasoning and make those statements. You put your thinking brains on there. All right, let's turn the page. We've got to identify a few more triangles. So now we've identified them by their angles. That's the acute, the obtuse, and the right. Those are angles. Now you got to identify them by their sides. So what their sides look like. So the first triangle that they have us take a look at is a scalene triangle. Scalene. And scalene means that all the sides are different. No sides are congruent, even if they might look kind of, sort of like they're congruent. If they don't have tick marks through them to show congruency, then they're not. They're not the same. So this particular triangle is a scalene triangle. Right? No congruent sides. All right? So scalene. Got to put that word to memory. S-C-A-L-E-N-E. All right, the next page, Braille page, and we're at the top of page 189.
Isosceles.
Isosceles. There are tick marks. Yeah. So take a look at this big old triangle in the middle of your page and notice that the top side and the right side, they have a tick mark through each of them. And you learned many, many lessons ago that tick marks show congruency, whether they look it or not, as if there's tick marks in there.
What's tick mark?
Yeah. You find a tick mark going through the top side?
Mm-hmm.
That one. There you go. Good. And then a tick mark through the bottom right. That means that those two sides are congruent. If you have two congruent sides, at least two congruent sides, you have what's called an isosceles triangle. Isosceles. Right? That's up at the top of your page. Isosceles. I-S-O-S-C-E-L-E-S. Isosceles. Two sides are congruent. All right? And then finally the next drawing shows the third way to classify a triangle by its side. The big old triangle in the middle of this page.
All of them are congruent.
Yeah, all of them have one tick mark through each of them, which means all the sides are congruent.
So this one is isosceles here.
It is an isosceles also, and then more specifically, it's an equilateral. But Abby, it is also an isosceles.
Wouldn't they all have to be acute also?
They will all be acute, and they'll all be 60 degrees. Because that's the only way we could divide up 180. If we're going to have three congruent sides, we'd have to have three congruent angles, and so they would all be 60 degrees. So an equilateral triangle will always be an acute triangle and will always have 60-degree angles. It's good thinking, Bryant. And Abby said, is it also an isosceles? Yes, technically it is. It's the same as a square is also a rectangle, isn't it?
Mm-hmm.
Because it meets the requirements. So notice an isosceles says at least two sides are congruent. Well, in an equilateral, at least two sides are congruent, so it's also an isosceles. But more specifically, we say it's an equilateral. All right? Equilateral. Equal sides. Yeah, lateral side. Equal sides. All right? So all sides are congruent. All right?
Mm-hmm.
All right. Turn the page. We got some information we need to read about. It says, since all sides of an equilateral triangle are congruent, then at least two sides are congruent. So just as Abby already predicted or stated, all equilateral triangles are also isosceles triangles. Some parts of isosceles triangles have special names. All right? Some parts have special names. So turn your page, and we have a new tactile page on page 189D. We have a triangle in the midst of it. Let's take a look at that. There's a whole bunch of information there labeling. So yeah. So we have two tick marks going through the left and right side. We have arrows pointing at different things. So it says, and back one page is going to label these things, but I'll help us out here. Where it has the number 1 pointing down to the very top vertex, when you turn back the page and read about number 1, what it says is the angle formed by the congruent sides is called the vertex angle. Vertex angle. Okay, so that very top angle, notice that the left side and the right side are congruent, are isosceles. So when those two come together, they form the vertex of an isosceles triangle. Right? The legs, they labeled each congruent side, they call it a leg. All right? And they've labeled those legs. And they have a little number 2 because if you turn back a page, it says the congruent sides are called legs. Congruent sides are called legs. And then they have a little arrow pointing at the left bottom angle and a little arrow pointing at the right bottom angle. And they've just labeled those base angles. And they say that in Braille, base angles.
Mm-hmm.
And if you turn back a page, they also say that on number 3 that those are base angles for your little key. And then they have an arrow pointing to the middle of the bottom side, and they've labeled that letter D, right? And they're saying, if you turn back the page, that the side opposite the vertex is called the base. So you have 2 legs and a base on an isosceles triangle. And you have 2 base angles. So even if it's not sitting in a position that feels as if it should be its base, this drawing could be skewed one way or the other. The base is always going to be the side opposite the vertex angle. The vertex angle is always the angle that's made up of the 2 congruent sides. All right?
This has
2 legs, yep, because it's an isosceles. Mm-hmm.
It doesn't walk though.
It does not walk. Ha ha ha. Mr. Walker, you're really funny. All right. Okay. And then also in more information on the previous page, it says 2 angles formed by the base and one of the congruent sides are called the base angles. All right. So that's just an anatomy of an isosceles triangle. So we're just going through lots of vocabulary and making out how we would identify a triangle and its parts. Why? Well, you might not always have a drawing. You might be told in a story problem that you have an isosceles triangle with legs that are 10 inches and a base that is 12 inches. You need to determine, the angle of the vertex, something like that. And you would not even have a drawing, so you would have to then kind of make it out based upon its words. All right, let's go do some practice. So turn the page to 189E. It says classify each triangle by its angles and by its sides. So you're going to love this section because it's pretty basic. It's just practicing this vocabulary. So you have a tactile in the middle of the page. You take a look at this tactile. You have a top vertex they've labeled E, a bottom left vertex they've labeled F, and a bottom right vertex they've labeled G. They have little arrow indicators labeling that the top at vertex E, angle E is 45 degrees. The bottom right at angle G is 45 degrees. And how much is angle F?
90.
90 degrees. Good. And then notice that there is a tick mark on side EF and a tick mark on side FG. So It is an isosceles triangle. What other kind of triangle is it?
Right?
A right. So notice we could combine two of them. We could say this is a right isosceles triangle. Triangle EFG, or we could name it GFE or FDE, however you want to name it, is a right isosceles triangle. Do we still get 180 degrees? 45, 45, 90? Yeah. This is a special triangle we're going to learn about later called the 45, 45, 90. All right, turn the Braille page. Braille users, print users, we're on number 2. Take a look at this triangle in the midst of your page. Pretty sizable one. Yeah, Jessica's yelling out
Acute.
equilateral.
Acute.
It's acute. You have a bottom left vertex A, bottom right vertex B, top vertex C. Notice a tick mark going through AC, a tick mark going through side CB or BC, and a tick mark going through AB or BA. And so this is an acute equilateral because they've labeled each angle 60 degrees, 60 degrees, and 60 degrees, which will always be equilateral. And 60 and 60 and 60 add up to what? 180. Check that out. All right. This is also an isosceles triangle, right? But more specifically, it's acute. Okay. All right, your turn. Next page, Braille page 189G.
So that one is
Scalene.
Abby's yelling out that this one is scalene. That is correct. Nicholson?
Did you guys have a good Thanksgiving?
We did. How about you?
Very nice and quiet.
Hello,
Yeah.
Mr.
Hey,
McKenzie.
Abby, how are you? Nice to see you.
We're warming up our brains with classifying triangles this morning.
Oh.
Yeah. All right, so this particular, Abby yelled out that this one is scalene.
Obtuse.
And Angelica's yelling out that it's obtuse. Why did Angelica say this is obtuse?
Because one of the angles is 122.
One of the angles is 122, more than 90 degrees and less than 180. Yeah. And then the other two angles, the angle at vertex X, they've labeled 25 degrees on the outside and have an arrow pointing to the inside. The vertex Z, that's your obtuse angle at 120 degrees. And
Oh, I see.
and then 33 degrees is your bottom vertex angle Y. How much do those all add up to? I wonder. 25, 33, and 122. 180. Yeah.
You did not scare me at all.
It just keeps adding up to 180.
You
Check
didn't
that
scare me at
out.
all, by the way.
I think our deductive reasoning is working.
You're
We
still
just
ahead of
keep
me.
getting 180.
Yep.
All right, next page on Braille page 189H. We have a big old triangle at the top of our page. Take a look at that one.
I think I know what it is.
What is it, Bryant?
Is it a scalene right triangle?
It is a scalene right triangle. Excellent. Yes. Scalene. So at the top, they've labeled that vertex L, and that's how many degrees?
90.
90. Good. And then the bottom right is vertex N, and how many degrees is that?
40.
40. Good. And the bottom left is vertex M, and how many degrees is that? 50. Excellent. So it is, and then notice there are no tick marks on any of the sides, and so they're scalene. I also want you to notice something else. So the last one, did we label the last one scalene also?
Oh, you're right.
Yeah.
We said obtuse. Do we say scalene?
Yeah.
So if we turn back a page and look at the obtuse scalene triangle, on page 189G. The angles are 33, 122, and 25, and this is obtuse scalene, isn't it?
Mm-hmm.
All the angles are different, aren't they? If we turn the page and we look at our right scalene triangle, we have 40, 50, 90. All the sides are different and all the angles are different, aren't they?
Mm-hmm.
Can we make another deductive reasoning statement maybe about scalene triangles?
Right. All the sides and all the angles are different.
All the sides and all the angles will be different. Yes. You're already coming up with your own postulates and theorems without even reading them yet. If we go back 2 pages to 189F, to our equilateral triangle, all the sides were the same and all the angles were the same. Aha, interesting. All right, so we probably can come up with a reason there too, can't we? A deductive reasoning statement. All equilateral triangles all angles will be equal, correct? Because they can only be 60. If we go back one more page to 189E, we get to that right isosceles triangle. We have a 45, 45, 90. Aha. We have 2 sides that are the same and 2 angles that are the same. So would it be safe then to deduce that on an isosceles triangle, if we have 2 sides the same, we will have 2 angles that are the same also?
Yes.
Yeah.
Mm-hmm.
Yes. Good. Excellent. Nicely done. I like when you turn your math brains on and think further than the book. All right. All right, let's go to the next page on 190. We got to do a little algebra. We can't let our algebra tools go to waste. So it says find the measure of
90.
sides
Is that
of
90?
AB 190. And it's number 3. It says find, it's 1, 2, 3, 4, 5 lines down in Braille. Find the measure of side AB and BC of an isosceles triangle, ABC, if angle A is the vertex angle. And then they have a drawing for us. So they gave us in words that this is an isosceles triangle with vertex A. So you put on your brains and you go, oh, that's right. If I'm told I have an isosceles with a vertex A, that means the 2 sides coming together to make the vertex are my legs. Those are my congruent sides, aren't they? So we have a triangle A at the top vertex, B at the bottom left, and C at the bottom right. And we know that BC is our base, don't we? All right, so then they're saying our sides are 5x minus 7 for side AB on the left and 23 for side AC on the right. And our base, BC, is 3x minus 5. And we have to find the measures of AB and BC. Well, very quickly, we should be able to tell the reader or the answer what is AB without even doing any math. It's 5x minus 7, but what's its measure? What's the measure of AB and you don't even have to do any math?
The measure of AB is 20.
It's 23,
Yeah.
yes. Jessica says it's 23.
I did too.
Right? Because those are our legs, and we know in an isosceles triangle those are congruent. So because you know that the right side AC is 23, you could say, hey, I know that AB is 23. So already half our question is answered. Now we have to answer what BC is, so we really do have to do some math. We have to find out what the value of x is so that we can substitute that value in for the x value for BC. So they do that in a little bit of a proof on the next page. They walk us through it. Right? So it says, you know that angle A is the vertex angle, therefore AB is congruent to AC. So your plan should be, since AB is congruent to AC, then AB equals AC. Remember, we can say sides and angles are congruent, and then we have to say measurements are equal. That's a technicality in geometry. You can write and solve an equation. So they have AB equals AC by the definition of congruent segments. Remember that from a long time ago? Then we have 5x minus 7 equals 23, and we're using the substitution property for that because we went back to our drawing and went, well, AB is 5x minus 7, and AC is 23, so we're just going to plug those in for both of those. Then now we do a little bit of algebra, and they add 7 to both sides because we want to isolate our x, and we have 5x minus 7 equals 23. We got to get rid of the negative 7 or minus 7, so we're going to add 7 to both sides. And they're just saying add 7 to both sides, but the property they're using is the addition property of equality. Then they simplify, so we have 5x equals 30. And then we're going to divide both sides by 5 because we can use our division property of equality, and x equals 6. Now, I bet one of the choices on a multiple choice test will be 23 and 6. Because they're going to try and catch the student that stops at finding the value of x and doesn't plug it in. All right, so you got to go back and plug in the 6. So that's what they say down below. To find the measures of AB and AC, replace x with 6 in the expression for each measure. Now I say, bah. I mean, they did it for AB, but we already know, don't we? That's going to be 23. So that was a little extra work, but that's fine. Well, let's do some extra work. So on the next page, they walk us through AB equals 5x minus 7. 5 times 6 minus 7, 30 minus 7 is 23. We knew that. But BC is the important one that we want to do because we don't know BC without substituting in that 6. So BC equals 3x minus 5. They substitute in the 6 for the x. 3 times 6 minus 5, 18 minus 5, or 13. So therefore, AB equals 23 and BC equals 13. That will be one of the choices on your test. It'll be AB equals 23 and BC equals 13. But I'll bet one of the choices would be AB equals 23 and BC equals 6 because they're going to try to catch the student that doesn't plug it back in. All right, and that would be a bummer because you did all that math and then didn't plug it back in. Right? And then they say since AB equals 23 and AC equals 23, the triangle is isosceles. All right? Fair enough?
Yeah.
All right, pretty basic, isn't it?
Yeah.
Yeah. Let's move all the way over to 190D. 190D. Let's do a little more practice. We want to classify each triangle by its angles and by its sides. You have a triangle in the midst of 190D. And it's pretty decent, it looks like. They have, now notice they have some measurements for the sides on this. They actually give us some units. 5.5 centimeters for the left side, 10.6 centimeters for the kind of top right side, and 6.5 centimeters for the bottom side. And then they give you your angle measures. The top vertex is 30 degrees. The bottom left vertex is 125 degrees, and the bottom right vertex is 25 degrees. So what kind of triangle is this classified by its angles? Obtuse, yes, obtuse. What is it classified by its sides? Scalene.
Yeah.
Notice again, put that geometry brain on. We have a 30, a 25, and a 125. They add up to 180. They're all different, right? So scalene triangles have all different angles and all different sides, right? Okay, kind of cool. Also notice the side opposite the 125-degree angle, so that top right side. It's 10.6 centimeters, isn't it?
Mm-hmm.
It's the longest side. Notice that I just want you to pay attention to that the sides opposite their angles are going to go in the order of their largeness, okay, or their smallness. So the side opposite the 125-degree angle, that's the longest side. The side opposite the 25-degree angle, so the one to the left, is 5.5 centimeters. That's the shortest one. It's the smallest angle. The side opposite your 30-degree angle is 6.5. That's the one in the middle, right?
Yeah.
That's an interesting, using your deductive reasoning, just kind of noticing that. We're already coming up with our theorems and postulates that we haven't even been told yet, just by noticing what's going on, right? Turn the page to 190 E.
Equilateral.
All right. Angelica's yelling out equilateral. Let's give the brailers a little bit of time to look at it. You concur?
Yes.
So it looks like they don't have tick marks, but they have measurements to the left and right of each side and the bottom, the base, and they're all 8 feet. So, okay, they're all the same. That means equilateral. And also they point out that we have 60-degree angles on the interior also. So we have equiangular. You're going to learn that term later. Equiangular is the same as equilateral. All right, good. So this is a acute equilateral triangle. Equilaterals are always going to be acute. All right, turn the page. Big old triangle in the midst of this page. There is no, let's see, they have 2 tick marks going through the left side and 2 little tick marks going through the bottom or the base. They have a right angle indicator. They have 45 degrees labeling the top vertex and 45 degrees labeling. It's not a scalene.
An isosceles right triangle.
It's an isosceles right triangle, correct. Isosceles.
No, I think that was it.
Because we have the 2 legs are the same,
90.
and the 90-degree angle creating the right. So this is an isosceles. Notice that the 2 leftover angles are acute, and they're 45 degrees, aren't they? They're the same. So isosceles triangle has 2 congruent sides and 2 congruent angles. The sides opposite each one of those are going to be congruent. Okay. Right, turn the page. Let's do a little bit of algebra. 190G. All right, it says triangle ABC is an isosceles triangle with a base of BC. So notice the base, it doesn't have to sit on its base. It can be floating out to the right there. So A is to the left, C is top right, B is bottom right. AC is 5. AB is 2x plus 3. And BC is 3x minus 1. Well, what do we know AB is for sure?
5.
5.
5.
Now we're going to make 2x plus 3 equal to 5, aren't we?
Yep.
All right. That shouldn't be too difficult. Oops, except I got to write it correctly. 2x plus 3 equals 5. What do we got to do?
Minus the 2.
Minus the
3.
3 from both sides, all right? So we get 2x equals 2. X equals what?
1
1.
or
That's
X.
not the answer, is it? X equals 1. That's not the answer because they want to know what BC is. So we have to go back and look at our drawing. BC is 3x minus 1. So what is BC?
Add one.
So if you know X is 1, what's BC?
5.
3x minus 1. So X is 1.
So 3X minus.
What's 3 times X? What's X is 1?
3.
2.
2.
Yeah, minus 1, 2. Good. There we go. Phew. All right, so AB is 5 because it's congruent to AC, and BC is 2 because we solved for X, making with our congruent sides, and we plugged that value in, that 1 in there. So 3 times 1 minus 1 is 2. All right? All right, you feel all right with this stuff?
Mm-hmm.
All right, I'll let you off the hook without homework today. Jessica Yomi.
Mm-hmm.
I got them in my emails this morning, and I'm going to grade them during prep, and I'll give you your scores tomorrow and go over them tomorrow, okay? All right. Everyone have a wonderful day. Happy December.
Yeah.
And no homework. All right, take care.
You too.
Bye.
Bye.
Bye.